Okay, so this stream I'm going to be studying parabolae. Parabolas, if you like. And parabolae have this sort of characteristic U shape, something like that. And they have three distinguished points and a distinguished line, which is used to actually define them. So like that. So I'll do RGB. Anyway, so that point right there is called the focus of the parabola. The green point right there at the base of the parabola is called the vertex. And the blue point, couldn't really find an agreed upon name for it, so I'm just going to call it the anti-focus. Other possible names would be the foot or the pole of the parabola. Anyway, so there's a geometric definition. Which is that you make a straight line like this, and then draw the shortest line that you possibly can to the directrix. We'll call that F, call that A, and we'll call that B. And it's that the distance F to A is exactly the same as the distance A to B, and a parabola is just the set of all points which satisfy that constraint. And so obviously here that means that the distance between the focus and the vertex and the vertex and the anti-focus is exactly equal. Okay, and so you could set up a parabola that way. And then another way that you can set it up on the xy plane is sort of like this. This is just making it so that the parabola sort of like opens upwards into the characteristic U shape, but you can swap the y and the x to sort of have it open up towards the right. And then, of course, you can introduce negative signs to make it open up downwards or towards the left. So, okay, what knowledge will I need here? Well, I'll need to know the coordinates of the focus and the vertex and the anti-focus. And I'll need to have an acceptable form for the directrix. Okay, so I'm going to introduce a very useful quantity called the discriminant, often symbolized by delta like that. The discriminant of the quadratic. And the way that you calculate it is b squared minus 4ac. Okay, so another obvious thing you could ask yourself is, where does it cross the y-axis? Where does it cross the x-axis? Where it crosses the y-axis is pretty obvious. It's just c. And where does it cross the x-axis? Well, for that, you can use the quadratic formula. or more basic techniques like factorization or completing the square if that's sort of what you're all about, but not today. Today I'm sort of analyzing it from this point of view. So for the focus, like we usually call them h, k, the coordinates of the focus. That's the x coordinate, that's the y coordinate. But you would want them in terms of a, b, and c, these coefficients right here, and h. Let's think about what the x coordinate of the focus would be. Okay, well, it's going to be whatever the sort of x coordinate of the line of symmetry of the parabola is, which is minus b over 2a. Okay, we've got that. And now what about the y coordinate? Minus delta over 4a. Okay, I've got it. That's for the focus. Vertex. Vertex. No, wrong. That's for the vertex. Oops, I got them mixed up. Okay. Vertex. Right there. Okay, focus next. Let's actually make sure. Okay, so we'll do one. Like that. Y equals 2x squared minus 3x at 5. And the discriminant minus b squared minus 4ac. Minus 31. Minus 31. Okay, so we want to point out the vertex. Okay, so one way is to get it into vertex form. The way to do that is by completing the square. So let's try that. So first factor out the 2. Then complete the square of that expression in there, which is a monic quadratic. Like that. Okay, so then I have to sort of balance it out. Okay, so secretly I kind of like expanded over here and then just balance the books. Okay, so I'll go ahead and do that. So and then that. produces that. So here we would have 9/8 on the end, and we actually want 5. So I have to add on 3 and 7/8. Okay, so the general vertex form is like this. Y equals A brackets x take h all squared add k. And that means that the coordinates of the vertex would be 3/4 and then 3 and 7/8 according to this. But then we have to check another way. The way described before. And that is minus b over 2a, comma, negative delta over 4a. All right, so I try that. So what is the negative of negative 3 all over 2? That's negative all over 2 times 2. That's 3/4. The discriminant in this case is negative 31, so negative 30 minus 31 all over 8. So that checks out. And let's plot. Oh, yay, look at that. We got the vertex. Okay, so next would be the focus. So it's going to be on the line of symmetry as well. So the x coordinate of the focus and the anti-focus is going to be negative minus b over 2a in both cases. But then if we have the y coordinates of the vertex, wouldn't it just be a fixed distance that way and that way? And wouldn't it be nice to have a name for that fixed distance right there? It does have a name. The name is the focal length. Often symbolized by P. And the focal length is 1 over 4a. So in this particular case, it would be 1 over 4a would be 1 over 8. 1 over 8. So it appears to be the coordinates of that vertex right there. The x coordinate at least. And then for the y coordinate, is that. There's the focus, there's the anti-focus. Okay, so right. K plus the focal length. K take the focal length. Like that. No. Like that. Okay. Right, okay, so anyway, the directrix. Hmm. Right, okay, that's enough of an introduction. Right, so now to find the vertex of each, I mean, you can do it over and over again by knowing that the line of symmetry is negative b over 2a, and then just substituting that in each and every single time to get the y coordinate. But that's quite a bother, isn't it? You could do it that way, but the better way is probably something like just having it on hand. So minus delta over 4a, and delta is the discriminant. Okay, so delta in this case is b squared minus 4ac, so that's 256 minus 4 times 64. So, well, actually, this is a special case, isn't it? Always be on the lookout for that. Okay, there. And so it will have a repeated root. And the repeated root is negative 8. and therefore the vertex is going 8 to the left and 0 up. Okay, but I have to prove it. You know what? I'll do it like this. Yeah. There you go. The vertex is negative 8, 0. All right. Okay, so I feel like this is going to be a bunch of special cases. Factor out 2. X squared minus 2x minus 1. We can see that that's a perfect square. That's the square root of x take 1. Okay, and so this will have repeated roots. The repeated roots, wait. There. One comma 0. No. No, that's wrong. Oh my goodness me. Okay. Right. No, you actually can't factorize it because b squared minus 4ac. Well, that's 2 root 2, so it doesn't work. Okay. Minus b over 2a, comma, minus delta over 4a. That's the vertex. So, minus minus 4. 4 over 4, that's 1. Check. Okay. 300, no, 24. The negative of 24 all over the negative of 4. Nine comma 6. All right, and could that have been done a different way? One and 75 won't do. 3 and 25 won't do. 5 and 15 will not do. And there is no other way to create it. Coordinates of the vertex, h comma k. The common form of this, or in terms of coefficients, minus b over 2a, because the vertex must lie on the line of symmetry, then minus delta over 4a. Find delta, which is b squared minus 4ac. So that's 144 minus 4 times minus 3 times minus 10 it's 24. Minus 12 over 2 times negative 3 minus 12 over minus 6, so 2. And then k is minus delta over 4a minus delta over 4a, so minus 24 over 4 times minus 3, so minus 12, so 2 comma 2. Okay, correct. Graph each equation. Okay. Y-intercept must be negative 3. Factorize. X take 3 times x plus 1. So the roots must be 3 and negative 1. Or the x-intercepts. And the vertex. Let's see if we can find that. As a reminder, that's minus b over 2a, comma, minus delta over 4a. Find the discriminant. B squared minus 4ac, so 4 minus 4 times 1 times negative 3. So that's 4 plus 12, so 16, which is a perfect square, of course. So minus b over 2a. So minus minus 2 over 2. So 2 over 2, so 1. And of course the line of symmetry, I can see it right there. I'm just getting used to the formula. Minus 16 over 4, so 4. Negative 4. So 1 comma, negative 4. That's the vertex. Okay. So notice that we can get another point on here just plugging into itself. 2 squared is 4, and 4 take 4 is 0, and take 3 is negative 3. So there you go. There, like that. There, like that. And we can always get more points. Plug in 4. So 16, take 8, take 3, that's 5. So 4 comma 5. And then this will just shoot off the page. There. Okay. The y-intercept would have to be negative 10. Now the roots, well, it's not factorizable, is it? So by the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. So find the discriminant first. B squared minus 4 times minus 1 times minus 10. That's minus 40. 36 minus 40 is minus 4. Negative discriminant means that it's floating above the x-axis, or in this case, floating below, because it opens up downwards. So we don't have to bother with the roots. No real roots. And the vertex. The vertex we find by negative b over 2a, comma, negative delta over 4a. So we apply it. That's negative b over 2a, comma, negative delta over 4a. The negative of negative 6 over 2 times negative 1. Cancel those out, so the negative 3. And we know that the y-intercept is negative 10 already. Okay, fine. Negative 4. Okay. Just so many negatives flying around. Negative. Put negative 4 there. And put it over 4 times negative 1. Like that. Okay, so those cancel out, so negative 1. Okay, great. Minus 3, comma minus 1. There. Okay, and it opens up downwards. So we just really have to plug in more points just to check. So if I plug in negative 2, Okay, I squared, I get 4. Times it by 6, I get negative 12. So minus 4 plus 12 minus 10 minus 2. There. Now plug in negative 1. Square it, you get 1. So negative 1 plus 6. Take 10, so 5 take 10, that's negative 5. There. 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 Find the minimum and maximum of each. Min-max value of each. Well, that's simply the vertex. No, that's wrong. Because the vertex is a point, a coordinate. And it has coordinates. If you want to find the min-max value of each, then you have to find the y-coordinate of the vertex, which is negative delta over 4a. Hello. So negative 16. Then the vertex is minus b over 2a, comma, negative delta over 4a. So we want the y-coordinate of the vertex. So minus 16 all over 4 times negative 1. Negative 4. So that would be the maximum value because it opens up downwards. Okay. But now we have to sketch the graph. Okay, so we've already got the y-coordinate of the vertex. Now we just need the x-coordinate. The x-coordinate is negative 8 over negative 2. So that's 4. So 4 comma minus 4. So, okay, so it's sort of positioned like that. Okay, and I want it to be more accurate, so I'm going to put in 5. So minus 25. So I do it like this, 5, and then colon, and then comes my workings out. So minus 25 plus 40 minus 20. And that's minus 5. So 5 comma minus 5. All right. There. Now I try 6. So minus 36. plus 48, and then take 20. So 12 take 20 is negative 8. So there. That's symmetric about the vertex. There. So carefully. Try and weave it through those points. There. Okay, but I want to check that the work is actually correct. 7 looks like that. Right, that's actually true. No. Minus 16 over 3, so minus 5 1/3. Plus the discriminant. Minus 4/3. There. will kind of look like that. F of x equals x squared at 2x, take 1. Well, for this, okay. The vertex is negative b over 2a, comma. negative delta over 4a, negative b over 2a, comma, negative delta over 4a, negative b over 2a, comma, negative delta over 4a. That's the vertex. And in this case, negative b over 2a would be 10 over negative 2, so negative 5. And then the negative of negative 20 over negative 4. Negative 20 over negative 4 is 5, and the negative of that is negative 5. So negative 5 comma negative 5. There's the vertex. And it opens up downwards. Oh, that's the maximum, by the way. And it opens up downwards. And I want to figure out, see if there's another point on here, although I don't think so. So I'm going to plug in negative 4. Then I plug in negative 3. Find the vertex, axis of symmetry, and the minimum and maximum value of each. So, just a reminder. This is a general form of a quadratic. And the discriminant is b squared minus 4ac. And the vertex is this, minus b over 2a, comma, minus delta over 4a. So the minimum or maximum would be the y-coordinate of the vertex. And you would judge whether or not it's minimum or maximum based on the sign of a. And what else do they want? They want the line of symmetry, right? So the line of symmetry is minus b over 2a. But what do I mean by that exactly? Because a line of symmetry is not a number. Well, it'll be a vertical line, and therefore it'll be x minus b over 2a. Vertex, axis of symmetry, minimum, maximum value of each. So, what's the efficient way to calculate this? First, find delta. Then Find the vertex. And then it's pretty simple. You just peel them off, just like that. Okay, so finding delta, or the discriminant, if you like. So just write triangle, b squared, like that. What's 54 squared? That's 2,916. What's 12 times 241? 2892, I believe. Something like that. So a gap of 24. Okay, delta is 24. The vertex would be negative b over 2a, so minus 54, so 54 over 6, which is 9, comma, minus delta over 4a, so minus 24 over 12, so minus 2. And because it opens upwards, the minimum value would therefore be minus 2. And the line of symmetry would be x equals 9, I believe. So let's check. 9 comma negative 2, negative 2 and 9. Yeah, okay, that's good. Okay, so the discriminant delta, b squared minus 4ac, so that's negative 18 squared minus 4 times 1 times 86. 324. What's negative 4 times 86? Negative 344. The discriminant is negative. That means that it has no real roots. Negative 20. Vertex is minus b over 2a, comma, minus delta over 4a. So minus b over 2a applied here is minus minus 18. So 18 over 2a, 18 over 2, 9. 20 over 4, which is 5. Opens upwards, so it has a minimum. The minimum is 5. Line of symmetry. X equals 9. So 9. So really 9, 5 just characterize it completely. Yeah. Okay, that's good. Okay. So, when you multiply a quadratic by like a fixed amount, anyway, b squared minus 4ac. So that'll be over 25, and so will that. So I'm just going to factor out 1 over 25. That would be simpler, right? And 48 squared is 2,304. 4 times 114 is 456. 456 times 4 1,824. And the difference between these two is like 480. And then 480 divided by 25. It's the same thing as 960 over 50, which is the same thing as 1,920 over 100. It's 19.2. 19.2. Or 19 and a fifth. 19 and a fifth. So 96 over 5. So now the vertex is minus b over 2a, comma minus delta over 4a. So 48 over 5 divided by that. The negative of that divided by the double of that. So basically 48 over 5 divided by 8 over 5. So basically 6. That's the x coordinate. And the y coordinate is minus delta over 4a. So minus 96 over 5 over that, over 4 times that. So 96 over 5 divided by 16 over 5, which is 6. So 6, 6. And the maximum will be negative 6. Will be 6. And the line of symmetry will be x equals 6. But I surely could have gotten this in a better way. Divide the whole thing by 4/5 and we get minus x squared plus 12x take oh no, you actually can't. 2 then. Hmm. 57? Really? Anyway. Better check if that's right. All right, it is. So, like, yeah, but so what? Anyway, delta plays. That's b squared minus 4ac. So that squared. There. No, wrong. Okay. Next. Use the information provided to write the vertex form equation of each parabola. I really want to learn this better. The vertex form of a parabola is y equals a brackets x take h all squared plus k. Where h and k are the vertex, coordinates of the vertex, h, k are the coordinates of the vertex. Try. Complete the square. X at 8 all squared, add 7. Okay, got it. Complete the square. To get the vertex form, x take 1 all squared, and when we square that out, we get x squared take 2x add 1, and we need to balance the books. So to get from positive 1 to negative 5, you take 6. And the vertex, in the case of this one, would be negative 8, 7, and we check x squared at 16x is 71. Negative 8, 7 is correct. Moving on. And the vertex in this case would be 1, negative 6. $59 is a prime number. But anyway, that's not relevant here. Square it out, you get negative 49. To get from negative 49 to negative 59, you take 10. So that like that. Let's check if that's right. Okay. Common factor of 2. Complete the square. You get 81 on the end. You double that, you get 162. But you need to get 170, so you've got to add 8 to it. So 2 brackets x add 9 all squared add 8. Check. Yes. Complete the square, so x takes 6 all squared. Square it out, you get x squared take 12x at 36, but you need 46, so add 10 to that, and you're done. Complete the square. That'll be x at 2 all squared, but you square that and you get x squared at 4, x at 4, but you need 0. So take off 4. Complete the square. So x take 3 all squared. Square that out, you get x squared takes 6x at 9, but you need 5, so take off 4. This is in factorized form. General form, vertex form, factorized form. You need to expand that out to get general form, x squared at 9x at 20. Complete the square, so half b, so x add 9 over 2, and then all of that squared. Square it out, and you get x squared at 9x at 81 over 4. 81 over 4 is 20.25. But you need 20, so take away a quarter. Let's check if that's right. X at 9 over 2 all squared, take a quarter. Yeah. Okay, so here, you know what to do here. Just sort it out. So like double both sides, and then take away 4 from both sides. So that would be y equals that, which is vertex form. Here you have it in the standard form, which is where you have the integers before them. Okay, so just move everything over. So y is equal to negative 6x squared. Take 12x. Take 13. And then you don't want that minus sign hanging around. In fact, we'll do this. There, like that. And when you square that, you get x squared at 2x at 1 times up by negative 6, so you get negative 6x squared. Take 12x, take 6. And we need negative 13. So we're going to take 7. So we'll check that. Oh, yay. Okay, it's right. Okay, here, move everything over. But the minus signs are going to confuse you, so just be careful for now. So just say 9x squared at 162x at 731. That's fine. Now flip the signs. Or better yet, just understand that it'll be like this. Okay. Factor out 9. 162 divided by 9 is like 18. And then that, where you complete the square of that, you get that. Okay, so we expand this out, and we're going to get negative 9x squared. Take. Yeah, that's right. Take 162x. 81 times 9 is 729. So it's take 729, but we need negative 731, so we've got to take off an extra 2. There. Let's check if that's right. Okay, wonderful. Okay, here, move it all over. Bring that minus sign out. No, wrong. There, like that. Complete the square. And expand it out and check what you need. Negative x squared plus, no, that's totally wrong. Halved at the wrong stage. There, negative x squared plus 12x, negative 36. So we need to go to negative 40, so take off an extra 4. And that's the vertex form. Here, complete the square. So we get x at 5, we'll square that out. So we get x squared at 10x at 25, and we need 33, so add on 8. And here, take off 6 from both sides. So there's vertex form. Now identify the vertex and axis of symmetry of each, then sketch the graph. Okay, better check the last two. Plus 5, plus 8, plus 3, take 6. That's fine. Okay. Now the vertex, when it's in vertex form like this, isn't the vertex quite literally? Because vertex form is y equals a, open brackets x take h, all squared take k, plus k, excuse me, and the coordinates of the vertex are h comma k. So here it would quite literally be 2 comma negative 4. Yes. So we need the vertex and the axis of symmetry, and then to sketch the graph as well. So the axis of symmetry is found by x equals minus b over 2a. So, but, you know, you already have the x coordinate of the vertex, don't you? So x equals 2 would be fine. We need to sketch the graph. 2 to the right, 4 down. There. When we expand this out here, we get plus 4, minus 12, take 4, minus 16. So the y-intercept is off the screen. So like minus 7 there. So that looks like a V, an upside down V, which it shouldn't be, but is that right? Yes, it is. Okay. That's good. Now the vertex. The vertex, you quite literally just peel these numbers off. So h comma k, so that would be 1 comma 4. and the axis of symmetry is x equals 1. So 1, 4, so it should be like there. The y-axis intercept, so we just sort of expand that out here, so we get 1, and then what's 1 times negative a quarter? That's negative a quarter at 4. It's 3 3/4, which makes sense as it's opening downwards. It's 3 3/4, so there-ish, and there-ish. But we need to sketch it accurately, so we need the roots of some kind. No. Well, the thing about vertex form is you can get the roots. So you just set it equal to 0. Like that. Take 4 from both sides, multiply both sides by 4 itself. Negative 4 itself to get rid of the negative a quarter. So it'd be 16 on the left. Equals x take 1 all squared. Square root both sides. So that'll be plus or minus 4. Like that. And then add 1 to both sides. So 4 add 1, that's 5. And negative 1 adds negative 4 add 1 is negative 3. So 5 and 3. 5 and negative 3. Like that. Sort of like that. Something like that. And then it will carry on. But it's much better to do these sort of like by hand, by pencil. Now, for this one here. Okay, so this is in vertex form. So the vertex and vertex form looks like this. And so the vertex is just h, k. So in this case, negative 4, 3. There, like that. And the axis of symmetry, minus b over 2a. So it's already there. So x equals negative 4. Like that. Yeah. Okay, and then in vertex form, you can actually get the roots. So just set it equal to 0. So 0 equals a quarter of x at 4, all squared at 3. But it's going to open upwards, and the vertex is there. So the roots will be complex, they'll be imaginary. They'll be complex conjugates, in fact. So no real roots. As for the y-intercept, squaring that, so we get 16. 16 times a quarter is 4. 4 at 3 is 7. So there. And there'll be 1 over here too. So sort of like draw like that. And there. We'll check. Negative 4, 3, and the axis of symmetry negative 4. Okay, so the vertex negative 5, 2, and the axis of symmetry x equals negative 5. So negative 5, 2 is there. And it opens upwards as well. So it has no real roots. And when we expand this here, we get x squared at 10x at 25, 25 over 4. 6 1/4, 6 1/4 2 is 8 1/4. So the y-intercept is sort of like off the screen over here. It's very... There's the axis of symmetry. And for this one here, yeah, I'm doing the volume of 3D shapes. They're coming up, but I don't know, it might be like a week from now, something like that. Okay, so the vertex here is negative 5, negative 3. So negative 5, negative 3, there like that. And this one opens downwards, as I can see by like the negative sign there. So it'll start out with negative 2x squared. So the y-intercept, what's that going to be? When I expand this out, I get x squared at 10x at 25. Negative 25 times negative 2 is negative 50. Negative 50 take 3 is negative 53. So it's way off the page. Way off the page. Put in negative 4 just to see it anyway. So 5 take 4 is 1. 1 squared is 1. Times negative 2, negative 2, negative 2 take 3 is negative 5. Okay, so there. And there. Negative 3. Okay, 2 squared, 4. 4 times negative 2, negative 8. Negative 8 take 3 is negative 11. So off the page. So, like that. And the axis of symmetry is going down the middle. Yeah. Okay. It's in vertex form. So the vertex h, k, so negative 2, negative 1. There. It opens upwards. And what are the roots? Set it equal to 0. So 1 equals x at 2 all squared. So plus or minus 1 equals x plus 2. So minus 2 plus or minus 1. So minus 3 or minus 1. And then the y-intercept upon expansion, we get 4. 4 take 1 is 3, so there. And there'll be a symmetrical one over here. And then putting in 1, we have 1 and 2, which is 3. 3 squared is 9, and 9 take 1 is 8, so there. And we have a matching one there. So the vertex is -2, -1, and the axis of symmetry is x equals -2. Kind of like that. Okay, all complete. Okay, next. Where is it? Quadratic inequalities. There. But I'll take a break here to eat an apple.